An electron configuration has three parts. The big number 1 represents the energy level, while the S represents the type of orbital. There are 4 types of orbital, which I'm going to discuss later on. And the superscript 2 represents the number of electrons in that orbital. A subshell is a group of orbitals. These are the 4 types of subshells: the S, P, D, and F. The S subshell contains up to 2 electrons, including the helium. The P subshell contains up to 6 electrons. The D subshell contains up to 10 electrons, and the F subshell contains up to 14 electrons. Now, let's move on to finding the electron configuration of the element vanadium. So, to find the electronic configuration of the element vanadium, we know that the periods on the left side of the periodic table represents the energy levels. Here, 1, S, 2, 2, S2, 2, P6, because there are 6 number of electrons. 3, S2, 3, P6. Go down 4, S2, then go up to 3, D3, 3D3. That's how we get the electronic configuration for the vanadium. So you ask me why this is 3 and not 4. It's because we're after the 3p, go up to 4s, then go down to 3d. 3p, go up 4s, then down 3d. Find the noble gas electron configuration of the element vanadium. The first step is to find the element on the periodic table, which is number 23. Go back to the last noble gas that was passed. From here, go back up. Last noble gas was passed was argon. And then write the symbol of the noble gas in brackets. Write argon in brackets. Continue the electron configuration using the row after the noble gas. Continue the electron configuration after the row. This row. And always begin with the S subshell. So for S2, continue 3D3. That is the noble gas electron configuration for the element vanadium. To find its valence electron is to look at the periodic table. Stated there that just below the atomic weight is its oxidation state or the valence. So let's try to find the vanadium on the periodic table. Right below the atomic weight, the highest valence electron, 5. So the valence electron of vanadium is 5.
Hi guys, I'm here to teach you how to find electrons configuration. So first, this row, this one until here, this one is the group of S.
She calls me day and night.
Here,
Sorry girl, you just
this
don't
one,
make me feel right.
this is the area of the S.
To make you
And
cry.
this one at the center is the area of D. So this and F. F is all here. This one. This is the side of B, and the F is this row. First, let's find SR. So SR is strontium. So there he is, the noble gas and the valence. So where will they get the valence? At the top of the noble gas. So we can find that one in the periodic table. Sorry guys if my periodic table don't have what do you call this one, the number at the bottom, but actually I forgot what's the name of it, so I'm sorry guys. So in the other video this is another example of how to find SR strontium. So in the other video you will know more. For the next example you will know more if what to do if you don't understand my video. Thank you and bye bye. So SR, so strontium, how to find electrons configuration. So here's the solution. The noble gas and the valence. So where will they get the valence? At the top of the noble gas. So where we can find that one in the periodic table. Sorry guys if my periodic table don't have what do you call this one, the number at the bottom, but actually I forgot what's the name of it, so I'm sorry guys. So in the other video this is another example of how to find SR strontium. So in the other video you will know more. For the next example you will know more if what to do if you don't understand my video. Thank you and bye bye. So SR, so strontium, how to find electrons configuration. So here's the solution.
There are three types of electron configuration parts. One number represents the principal energy level, while number 2 represents the number of electrons. S represents the orbital shape. There are four types of subshell. The first one is the S subshell. where it contains 2 numbers of electrons, the p subshell that contains 6 numbers of electrons, the d subshell that contains 10 numbers of electrons, and last, the f subshell that contains 14 numbers of electrons. Examples of electron configuration of boron. Boron electron configuration is 1s2, 2s2, 2p1. Why is it that 2p1 is the last number of electron is attached instead of 2p6? It's because boron element is located at the fifth base of the elements, where if you add all the elements, it would be 5. 2 plus 2 plus 1 equals 5. Here, if you add that, the valence is 3 and the noble gas is He2S2 2p1.
Today we're going to find the electron configuration for lithium. So how to write electron configuration for lithium? So by now, I should be confident in knowing the SPDF. Electron shells is important to remember that they hold 2, 6, 10, and 14 electrons. So let's get to our example, lithium. We need first define the number of electrons. We can do that by looking at atomic number, the above number of the element symbol on the periodic table, and that will tell us the number of proton, but it will also tell us the number of electrons, and we can use that number to find number of electrons to write the electrons configuration for lithium. We use the chart at the right to place the 3 electrons for the lithium atom around the nucleus. So we can start with the table and we go down the 1s row that gives us 1s orbital, and s orbitals can hold up to 2 electrons. So we can put those 2 electrons there as the superscript to show that we have 2 electrons in the s orbital. And then we go down the next row, which is the 2s. Then we put a 2s here, that's the 2s orbital, and we already get 2 electrons in the 1s orbital. So get 3, we only need to put 1 in the 2s orbital if you add those up to 1 plus 1, that give us 3, which is how many electrons we have for lithium. So that's electron configuration for lithium. Thank you.
An electron configuration has 3 parts. The big number 3 represents the number level, while the P represents the type of orbital, and the superscript 6 represents the number of electrons. there are 4 types of subshells: the S, the P, the D, and the F, this one. So the S subshells contain up to 2 electrons, the P subshells contains up to 6 electrons, the D subshells contains up to 10 electrons, and the F, the last one, the F subshells contain up to 14 electrons. So next, the electronic configuration of sodium. R1s2, 2s2, 2p6, and 3s1. The electronic valence is only 1, as you can see here, 1. And the noble gases of the sodium, argon, so 3s1, Ne3s1. That's all, and thank you.
So, Mountain of Roses, everyone. My name is Hannah Athalia Villagana from grade 12 STEM Mount Duval. So, Sir Ray gave us 30 elements to pick one of them. And I chose the element oxygen. The noble gas was passed is helium. And don't forget to put it inside a bracket. Then let's continue the electron configuration. 2, 2, S2. And 2, P4. And to get the valence, to get the electron configuration of oxygen, first we need the periodic table. The electron configuration of oxygen is 1s2. And 2s2. And 2p4. And to get the noble gas electron configuration, we need the periodic table. It's right here, the oxygen. It's in group 16, sometimes called 6A. That means it has 6 valence electrons. So this is my answer. electron configuration 1s2, 2s2, and 2p4. The noble gas electron configuration is helium 2s2 and 2p4, and the valence is 6. So that's all. Thank you.